learners, welcome to this lesson. I'm teacher Agnes and today we are going to be discussing length. Alright, length. So length, when we talk about length, if you look at this pen, it has its own length. So when you talk about the length of the pen, we mean the distance from this point to this point. This is the length of this pen. If you look at this phone, it has its own length from here to here. So how do we define length? We define length as the distance between 2 points. Alright? So any distance between 2 points, if you have a line here, it has 2 points here, and the distance between them is referred to as length. Now we have several units that are used to determine length, but the major unit, which is the SI unit of length, is the meter. Okay, the meter, which is represented by small m. However, we have other units such as kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters, micrometers, and so on. So we are going to look at the common units that are used in measurement of length. The first one is kilometers, denoted by K and M. Then we have hectometers, decameters, meters, decimeters, centimeters, and then millimeters. So I know this is not new to us. We know that between any two units that are following each other, we have 10 units. So between any two units, we have 10 units. So if you want to know how many hectometers make up 1 kilometer, then we would say that 1 kilometer is equal to 10 hectometers. If you want to know how many decameters make up 1 kilometer, then it would be 1 kilometer is equal to 10 times 10, which is 100 decameters. If you want to know how many millimeters make up 1 meter, 1 meter would be said to be equal to 10 times 10 times 10, which is 1,000 millimeters, and so on. Now, these units follow in order, and I know you have a mnemonic for remembering this order. So the one that I know is that Kenya has dug many dams containing maji. So the first letter of every word gives you the first letter of these units. Kenya, K, has, H, dug, D, many, M, dams, D, containing, C, maji, M. So anytime you want to derive a comparison between these two, always begin with the largest. So if you are converting from a larger unit to a smaller unit, if you want to convert 3 kilometers to millimeters, then you would have to multiply. So you multiply, and if you are converting from a smaller unit to a larger unit, you divide. But you divide by what? Like we have said, you can choose the relationship between any two units from this. If it's kilometers and meters, you just check. We have 10 times 10 times 10 in between kilometers and meters. That makes 1,000. So the bigger unit, which is 1 kilometer, will be equivalent to 1,000 meters, and so on. So at this point, I want us to do a few conversions. To begin with, I want us to convert 0.08 kilometers to meters. So we have said that for you to convert from kilometers to meters, you just check. We have 1, 2, 3. 10 times 10 times 10 is 1,000, meaning that 1 kilometer is equal to 1,000 meters. So converting from kilometers to meters, we multiply. So now to convert from kilometers to meters, we are going to multiply by 1,000. So 0.08 times 1,000, which is equal to the decimal point, you move forward 3 times, So we have 80 meters. 80 meters. Now next, we are going to do another conversion. We are going to convert 500 millimeters to decimeters. So in this case, we are going to look at decimeters and millimeters. So from decimeters to millimeters, we have 10 times 10, which is 100, meaning that 1 decimeter, which is a bigger unit, is equivalent to 100 millimeters. Now you notice that you are converting from millimeters to decimeters. You know, we are moving backwards. So that means you're going to divide by 100. So this will be 500 divided by 100, which is equal to 5 decimeters. So I want us to do one final conversion. We are going to convert 0.6 hectometers to centimeters. So from hectometers to centimeters, we have 10 times 10 times 10 times 10, that is 10,000. So 1 hectometer is equal to 10,000 centimeters. Now since we are converting from a bigger unit to a smaller unit, then we multiply. So we will have 0.6 times 10,000, which is equal to 6,000 centimeters. So what we have learned today is how to convert between the units of length, and all you need to do is to remember this formation, and that between any two units we have 10 units. So now we are going to look at how to determine the value of significant figures in a number. So in math, we have different methods of approximating numbers, and one of them is to write them correct to a specified number of significant figures. The distance between Nairobi and Mombasa is actually 489.562 kilometers. If someone was to ask you in real life the distance between Nairobi and Mombasa, and you tell them it's 489.562 kilometers, they'll look at you like, what are you saying? So this number can be approximated. So if you approximate this to about 490 kilometers, then it sounds more realistic. This is something that you can chip in and say in a conversation. So when you approximate numbers, you follow rules. And when writing numbers correct to significant figures, there are rules that are followed. So we are going to highlight those rules so that we are familiar with them, and then you can attempt to write numbers correct to a specified number of significant figures. Number one is that you need to know that all non-zero digits are considered significant. Okay? All non-zero digits are considered significant. So if you have a number like 487, then the number of significant figures in this number are 1, 2, 3. So these are 3 significant figures. If you have a number like 12.48, then here we have how many significant figures? 1, 2, 3, 4. So all non-zero digits are considered to be significant. Number 2, zeros between non-zero digits, are significant. So the task here is to know, when are zeros said to be significant, when are they not significant, because all the other digits are significant. So if you have a 0 between two non-zero digits, for example, 504, this 0 is considered to be significant. So here we have 1, 2, 3 significant figures. Another example would be 4.09. This 0 is between two non-zero digits, so it is considered to be significant. Therefore, in this number, we also have 3 significant figures. Now, zeros that come on the left side of the number are not significant. So zeros on the left hand side of a number are not significant. By this we mean, if you have a number like 0.0078, you realize that these zeros on the left side of the number are the ones that are starting the number. So the first significant figure will be 7 because these 3 zeros are considered insignificant. So a number like this has only 2 significant figures. Another example would be 0.4. This 0 is not significant, so this number has 1 significant figure. Now, what about when zeros are on the right hand side of a number? Are they considered to be significant or not? Now, if you have zeros on the right hand side of a number, they may be or maybe not significant. What do we mean? If you have a number like 28,000, the 3 zeros here can serve 2 purposes. One, they can be there as significant figures, or they can be there to represent the value of the number. When we start doing examples, you are going to understand this better. So this number, if you want to write it to 2 significant figures, it's not going to change. It's going to remain the same. To 3 significant figures, it's going to remain the same. 4 significant figures, the same. 5 significant figures, the same. So you see, there are times when zeros may be considered significant and others not. When we do a practical example, this will sink in better. However, if you have a number like, let's say, 2.50, same case applies to the 0. There are times when it's going to be significant, and there are times when it's going to be insignificant. So what we're going to do now is do some examples, writing numbers correct to a specified number of significant figures, and then practice the 4 rules. Alright, so now we are going to write these numbers correct to 2 significant figures. Express each of these numbers correct to 2 significant figures. So when writing numbers correct to 2 significant figures, remember the 4 rules that we have stated. Now the process is you start counting from the left hand side of the number. So this is the first significant figure, second, so put a stroke there, check the third number. If that number is 5 or more, then you round it up by adding 1 here. If it is less, then you round it down. So in this case, we are going to round up 1 so that this remains as 4 and this as 9. Now, remember writing numbers correct to a given value of significant figures is a method of approximation. So you need to ask yourself, Does this make sense? Can we approximate 489.562 to 249? That's too low. The value of this number has been compromised. So to ensure that you retain the value of the number, then you have to turn this into 0. You don't need the decimal points turned into 0 because they will not be adding to the value of the number. So this to two significant figures will be equal to 490. So this is what we were saying. At this moment, this 0 here is not there as a significant figure. It is there to increase or rather to maintain the value of the number. Let us look at example 2. We have 807,235. So we count 1, 2, put a stroke. Looking at 7, it's greater than 5, so we add 1 here. So this becomes 81. But can we leave it at that? No, because we will have compromised the value of the number. So the rest of the numbers, since we don't have decimal places, will be turned into 0 so that our final answer is 810,000. And it makes sense to approximate 807,235 to 810,000. Next, we have 258,000. So again, 1, 2, put a stroke. 8 is greater than 5, so we add 1 here, and this will become 26. Then the rest will become zeros, so 260,000. Then we have 14, so we count 14,000. 1, 2, 0 is less than 5. So we are not going to add 1 to 14. It's just going to be 14. But to retain the value of the number, the rest of the values will become zeros. So 14,000 has been approximated to 14,000. Then now, here we have 0.06751. So we need to start counting from 6 because zeros that are on the left side, hand side of the number are considered insignificant. So we start counting from 6 being our first significant figure. So 1, 2, then we put a slash there. This is 5, so we add 1 here. So since we didn't count the 2 zeros, we must still include them in the answer, because if we don't, and we just write 68, we will have changed the value of the number. So the 2 zeros here are present to maintain the value of the number. So this becomes 0.068. 4.07 to two significant figures. So this 0 is between 2 non-zero digits. It is significant. So when we start counting from 4, this will be our second significant figure. So we put a slash there. Looking at this 7, it's greater than 5. So we add 1 here, and this will be equal to 4.1. Okay? Yes. Then 7 only has one significant figure, but we want two significant figures. So this will be 7 point. We add an extra significant figure that will not change the value of the number, which is 0. So 7.0 is 7 written correct to two significant figures. So this is how you write numbers are correct to significant figures. And for your practice, I need you to write the following numbers correct to 3 significant figures. So write 18.47 correct to 3 significant figures, 0.008147, C 81,000, D 40,428, and then finally 18. Write these numbers correct to 3 significant figures. Now, we are now going to look at how do you determine the perimeter of objects, because we said length is a difference between any two, is a distance between any 2 points. So if you have a figure, how do you determine its perimeter? Now we are going to look at perimeter. When we talk about perimeter, what do we mean? So perimeter is the length. If you have a plain figure that has more than one side, like a rectangle which has 4 sides, and then you add the values of the distances of all the sides, then you will obtain the perimeter of that figure. So we say that perimeter is a total distance, around a figure. So we're going to start with a figure that has 3 sides. So if you have a rectangle, so if you have a triangle, that has 3 sides, and this is A, B, and C, then the perimeter will be equal to A plus B plus C. So the length here is A, the length here is B, and the length here is C. So the total distance around this figure is the one that is going to be equal to the perimeter. So this is the same case when you have figures that have 4 sides, like if you have a square, side and side. So the perimeter would still be equal to side plus side plus side plus side. If you have a rectangle that has this as a length and this as the width, this is still the width and this is the length, the perimeter will be equal to length plus the other length plus the width and then plus the other width. If you have a trapezium, okay, and this is A, B, C, and this is the height, the perimeter will be the sum of all the sides, A plus B plus C plus height. So it doesn't matter how many sides the figure has. All you have to do is to ensure that you add the distance of every side. And when you have added all of them, then you will have determined the perimeter of that figure. So now, using more practical examples, here we have a figure of this shape, okay? And this distance here is 10 centimeters. Here we have 5 centimeters, 3 centimeters, 4 centimeters, this is 6 centimeters, and this is 8 centimeters. If you need to determine the perimeter of that figure, then you will have to add all the sides. So the perimeter will be equal to, so for this side we have 10 plus 5 plus this side is 6 plus this side is 3 plus this side is 4. Finally, we have this side which is 8. So if you add them all, 10 plus 5 is 15 plus 6 which is 21 plus 3, 24 plus 4, 28, then plus 8, you obtain 36 centimeters. Now I need you to notice that the units of perimeter are the same as the units of length. We don't have centimeters squared, centimeters cubed, no. It's just centimeters because perimeter is just different lengths that have been added together. If you have another figure, so for a rectangle, you would be given the value of 2 sides. This is 20 centimeters and this one is 10 centimeters. So it is up to you to know that a rectangle, the opposite sides are equal. So that means that if this side is 20 centimeters, then this one is also 20 centimeters and this one is 10 centimeters. So the perimeter will be equal to the sum of all the sides. 20 plus this as 10 plus this as 20, then plus this as 10. So this will be equal to 20 plus 10, which is 30, then plus 20, 50, plus 10, which is 60 centimeters. The takeaway here is that anytime you have a two-dimensional figure and you need to determine the perimeter, you need to add the lengths of all the sides. Now, in some questions, you are given the perimeter itself and maybe one side, like in the case of a square and a rectangle, and then you're asked to determine the value of the other side. So how do you approach that? So now here we are dealing with two scenarios. In the first one, we have rectangles, and then in the other one we have triangles. So in the case of rectangles, we know that if this is a rectangle and this is L, L, W, W, the perimeter will be equal to adding the two lengths. So we have 2 lengths plus 2 widths, okay? 2L plus 2W. So in a case where we are required to determine the perimeter, like you can see, this is a column for length, this is a column for width, and this is a column for perimeter. In the first scenario, we have the length and the width. What do we need? The perimeter. So applying this formula, this will be equal to 2 times the length, which is 15, plus 2 times the width, which is 8. This will be equal to 2 times 15, which is 30, plus 2 times 8, which is 16. When you add the 2, you obtain 46. So the perimeter, when the length is 15 and the width is 8, is 46. Now, in the next section in the table, we do not have the length, we have the width, and we have the perimeter. So in this case, the perimeter is 24. So looking at this formula, we will have 24 being equal to 2 times the length plus 2 times the width, which is 4. So this is 24 being equal to 2L plus 2 times 4, which is 8. So if we take 8, this other side of the equation, it's going to be subtraction. And 24 minus 8 is the same as 16, which is equal to 2L. Now, we are required to determine L, not 2L. So we have to divide by 2 in both sides so that 8 will be equal to the length. So in this table now, we can fill this as 8. So next, here we still don't have the length, but we have the width and we have the perimeter. So the perimeter is 40. We are still working with this formula. This will be equal to 2L plus 2 width, so 2 times 7.5. So 40 will be equal to 2L plus 2 times 7.5 is 15. Taking 15 to this side will be subtraction. So 40 minus 15 is going to be equal to 25, which is equal to 2L. Now to determine the value of L, we will have to divide by 2 in both sides to obtain L as 12.5. So 12.5. So this is how you approach a question where you have the perimeter and one of the sides. Alright? Is that the same case when it comes to a triangle? So when it comes to a triangle has 3 sides, A, B, and C. And then we have the perimeter here. So the formula for getting the perimeter of a triangle is perimeter is equal to A plus B plus C. So in this case, we have A, B, and C. So if we add them, we will have 5 plus 6 plus 10, which is equal to 5 plus 6 is 11, plus 10 is 21. So this will be equal to 21. Next, we have A, we don't have B, we have C, and we have the perimeter. Are we able to determine the value of B? If we substitute in this formula, the perimeter is 50, which is equal to A is 8, plus B, we don't have it, plus C, which is 10. So for us to obtain B, we need to add 8 and 10, which is 18. 50 is equal to 18 plus B. If we take 18 to the other side, then we have to subtract it. 50 minus 18 will be equal to 32, which is equal to B. So our B here is 32. Now what if we don't have A, but we have B and C, and we have the perimeter? So it is the same case. The perimeter is 20. According to this formula, we are going to substitute. So the perimeter is 20, which is equal to A, we don't have A, B is 5, and then C is 8. So 5 plus 8 is equal to A plus 13. So for us to obtain A, we have to take 13 to this other side. So 20 minus 13 is 7. So our A will be equal to 7. So this will be equal to 7. So that is how you determine the value of one side given other sides and the perimeter. And that brings us to the end of this lesson. I'm just now going to give you a few questions that you will attempt on your own. So learners, to practice what we have learned today, determine the perimeter of these three figures. Thank you so much for being in this lesson. See you in the next lesson.